What exactly is a fluid? A substance usually exists in three phases, that is solid, liquid and gas. Both liquid and gas come under the category of a fluid. What is the difference between a solid and a liquid? It is solely based on its ability to resist an applied shear stress. In this video, you can see the solid stops deforming after a limit, but the liquid deforms continuously upon the action of a shear stress. What is shear stress? Shear stress is the stress that causes the material to shear. How a solid deforms upon a shear stress? You can see a solid placed between two plates. The solid is fixed between two plates. When a tangential force is applied, a shear stress acts on the solid at the top. The shear stress is equal to the tangential force by the surface area. An equal and opposite shear stress is developed at the bottom to counter the shear stress at the top. This causes the solid body to deform. If the shear stress is within the elastic limit, the solid stops deforming, and when the shear stress is removed, it returns to its initial position. The shear stress causes a shear strain, which is defined as delta x by delta y, which is equal to tan theta. And since theta is small, tan theta can be approximated as theta. If a fluid element is kept between two plates when a shear stress is applied, just like the earlier case, the fluid will deform continuously without offering any resistance. So, the definition of a fluid is that any substance which deforms continuously upon the action of a shear stress, however small it is. In the case of a fluid, instead of shear strain, we take the shear strain rate because the plate is moving continuously without any resistance. So shear strain rate is equal to d by dt of tan beta, and tan beta is equal to delta x by delta y. So shear strain rate is equal to tan beta dot, that is equal to d by dt of delta x by delta y. And tan beta dot is equal to delta u by delta y, because d by dt of delta x is equal to delta u. And when the limits are applied, tan beta dot is equal to du by dy. In solids, shear stress is proportional to strain. That is, tau is directly proportional to tan theta. In fluids, shear stress is proportional to strain rate. That is, tau is directly proportional to tan theta dot.